Hello, Brookfield High School Honor Pre-Calc students. We are going to be graphing a tangent today. I'm going to turn you over to Math Guru, Mr. DeStasio, and he will take this program over at this point.
Thank you, special guest. All right, so we have already learned how to graph the sinusoidal functions, so now we're going to look at graphing the other trig functions. And today we're just going to look at the tangent function. So that means we're going to be graphing this function on the xy coordinate axis, where the x-axis is our angle and the y-axis is the length of our tangent segment. First, recall that the tangent function is the quotient of the sine and cosine function. So what we're going to do is we're going to start by making a table of values for the quadrantal angles. So we are going to remember that when we want to, this is going to end up being our y value here, this column. Okay? And this is our x value. So these are the points that are going to show up on our graph. These are the x's and the y's. The sine and cosine will just sort of help us get there. And remember that tangent is going to be sine of x divided by cosine of x. And then this will be the point that actually shows up on our graph. All right, so for the quadrantal angles, that just means the angles that are right on the axes as we go around the unit circle. So if I think of the angle 0, so if I draw my unit circle over here, we're talking about this first angle right here, 0, that has an x-coordinate of 1 and a y-coordinate of 0. So the sine value there is 0, because that's the y-coordinate, and the cosine value is 1. That means the tangent is going to be sine divided by cosine, so 0 divided by 1 is going to be equal to 0. So that means that point that's going to show up on the tangent xy plane tangent graph will be 0, 0. Let's move to our next quadrantal angle. If we go to 90 degrees, or pi over 2, we are here on the unit circle, and that point is going to be 0, 1. So that means the sine value is 1 and the cosine value is 0. Tangent is sine divided by cosine, so it's 1 divided by 0. Anytime we try to divide by 0, that's undefined. So what's going to happen there on this graph is we are going to have a vertical asymptote. I don't have enough room here to write that, so I'll just say ASYN. Okay? So, actually, I can just do it this way, right in there. That's going to be undefined tangent. So on the graph, we don't have a point. We have a vertical asymptote. It's okay if that goes on. So at that x value, we'll have a vertical asymptote. Now, let's move to the next quadrantal angle. If we keep going over to pi, that point is -1, 0. So our sine value is 0 again. Our cosine value is -1. So tangent's going to be sine divided by cosine, and that's going to be equal to 0. So that point on the graph is going to be pi 0. If we go to our next quadrantal angle, we're down here at 270 degrees, or 3 pi over 2. The coordinates of that point are going to be 0, -1. So that means our sine of x is -1. Our cosine is 0. So tangent is going to be -1 over 0, which again is undefined. What we're going to have there on the graph of tangent is a vertical asymptote. And then lastly, we come back around to where we started and we finish one complete rotation. So that would be kind of its period. And we're at 2 pi, or it may not be its period because it actually repeats faster than that. But we've gone all the way around the unit circle. And so the coordinates at that point again are 1, 0. So the sine value is 0. Everything's going to be the same as 0 because we're at the same angle. So 0, 1, 0 for the tangent. And we're going to have the point 2 pi 0 on the graph. So let's take a look at what the graph of tangent will start to look like. Ooh, that was a bad line. Sorry, we're in the car. Okay, so I'm going to get my quadrantals on the graph here. So I've got 0, I've got pi over 2, I've got pi, I've got 3 pi over 2, I've got 2 pi, and then it would just sort of repeat again. So we don't need to do that. So it's 0, 0. At 0, we have the graph 0, 0. At pi over 2, we had this vertical asymptote because the denominator becomes 0 there. At pi, we said the tangent segment, or the tangent function will be 0. At 3 pi over 2, we get this asymptote again. And then at 2 pi, it's back to 0. And then that would just repeat. If we went to 5 pi over 2, that would be kind of the same thing as pi over 2. So we can see that every time here we get to one of these y-axis quadrantal angles, we're getting a cosine value of 0, which means we're dividing by 0, which means we get this vertical asymptote. And that happens, the distance between those, right, is every pi units. And the same thing, or a similar thing happens with the x-axis quadrantal angles. The y value keeps becoming 0 every time we hit those. So now the question is, what is the graph doing kind of in between these sections here? So this is like quadrant 1, right? Because the angle goes from 0 to pi over 2, then from pi over 2 to pi, right? This is like quadrant 2, what's happening. This is quadrant 3, and this is quadrant 4, and then the whole thing would repeat again. Because then we're back in quadrant 1 here. So we'd be just repeating over and over. So we really want to look at these 4 sections, what's happening in there. And to do that, well, first of all, we should remember that where is tangent positive? When we graph these, let's keep in mind that in quadrant 1, tangent is positive. In quadrant 2, tangent is negative. In quadrant 3, tangent is positive. And in quadrant 4, tangent is negative. So we have this alternation going on here. So that means anything we want to graph, it's got to be above the x-axis when the tangent is positive, and anything that's whenever we're in the negative part, like quadrants 2 and quadrant 4, the graph's got to go below the x-axis. So we have that in mind. To find out what else is happening, we're going to think about the length or the size of the tangent segment. We've already determined when it's positive and negative. So we're not going to think about it if it goes up or if it goes down, that makes it positive or negative. We're just looking at the size of it. Okay, so let's recall our drawing using the unit circle and the segment named the tangent segment to fill out what happens in between these gaps here. So if we recall this picture, our tangent segment is going to be the one that we draw tangent to the circle. Our angle is theta, and this segment is tangent of theta. So we're making a relationship, remember, of all the coordinates where theta is the x coordinate, the size of the angle is the x, and then the length of that segment is the y. So we want to see in quadrant 1 when we go from 0 to an angle of 0 to an angle of pi over 2. So just in this quadrant, what happens to the length of that segment? So I made a little Desmos here for us to look at that. Hopefully it loads. Okay. Let's see here. I don't want to save that. I already have it. Okay, so here's our length of our tangent segment I just made. So you can see that as I drag this point and change the size of the angle, you can see the length of the tangent segment changing. So when we're all the way here at 0, we already said that tangent segment is 0. And as I start increasing my angle towards pi over 2, the tangent segment gets larger and larger and larger. And it gets larger the closer I get to pi over 2, the segment gets larger faster. Okay, so it starts at 0 and goes up and just keeps getting larger and larger and grows unbounded. So that's what's happening in this quadrant 1 segment over here. We start at 0 and it starts growing slowly, but then it grows faster and faster and grows unbounded and goes up to infinity. Okay? And it's above the axis because remember in quadrant 1, our tangent is negative. Now, what would happen in quadrant 2? This graph that I have for you here, it doesn't really show the tangent segment on the other side, but you could picture it. As I just pass and go on the other side here of pi over 2, I would have a really large tangent segment, and then as I come down, ignore that one in the bottom right. As I come down, the tangent segment will get smaller and smaller and smaller because it's this segment kind of over here, just on the other side. It would start really big, and as I came back down towards the y-axis, it would get smaller and go towards 0. That's what's happening in quadrant 2. So remember, we're over here. It would be really high, coming down, and as this point gets closer to the x-axis, it would approach 0. So it's really large at first and then approaches 0. So we're going to draw it down here, a really large negative number, which is really small, but the length of the segment is really large and it's negative, and we start getting closer and closer to 0 until we get to 0. Okay? It's below the axis because we already know that tangent is negative in quadrant 2. So that's what's going on here. So here's a better graph of this, right? So we can see that it grows up. This is like quadrant 1. This is quadrant 2. It's what we said. It's really large, negative, comes into 0. Then this is quadrant 3, which we know tangent's positive, so it's back up above the x-axis again. And it's going to do the same thing. If you picture that segment, as we go from, the angle goes from pi in the unit circle. Just look at the dot. Oh, it disappears. Well, as we go into quadrant 3, think of that length of that tangent segment again. It starts off at 0 and gets larger and larger, faster and faster, so that's why it shoots up. And we know the tangent in quadrant 3 is positive, so it's above the x-axis. And then same thing happens here in quadrant 4. The segment starts off as we go past 3 pi over 2 and come back to 2 pi. It starts off as a really long segment, but it's negative because we know tangent's negative in quadrant 4, and it approaches 0, okay? And then when we get to 2 pi, it stops. And that is kind of one period when we go around the circle, okay? But we're going to talk about why the period of tangent is actually pi. When I say one period, I'm just kind of saying that one time around the circle. I really shouldn't say period there. So we know that this is a sufficient graph, and we can just keep repeating. So I would take this piece now, and we just put it here, and it starts all over again. So it looks like tangent just looks like this over and over. My question to you would be is, can you come up with what would happen over here? I'd want you to pause and think about that before we look at it. So do that. Okay, welcome back. So this would represent negative angles. If we rotate it in the opposite direction, the graph would kind of come down here, and then it would just look the same. So it looks like this graph is repeating every pi, actually, because we know tangent's the same in quadrants 1 and 3. So we don't have to wait for a full rotation for it to repeat. It repeats every pi, so the period is going to be pi of tangent. Let's look at a tangent graph without all my crazy writing on it. We don't want to go to the College Board. Let's look at a graph of tangent. So you can take a look at a graph here. There's a whole bunch of different images. Let's go in images and take a look. So you can see that it repeats every pi. So from negative pi over 2 to pi over 2, that's a period. Or you can look from pi over 2 to 3 pi over 2, or from 0 to pi, it just keeps repeating every pi. But that's what the graph of tangent looks like.